Hey guys, welcome to day 72. So today we're going to talk about line of best fit and curve of best fit. But before we get into it, I want to start talking about a scatter plot. So a scatter plot is a graph that's used to determine whether there's a relationship between the paired data. So scatter plots can show trends in the data. So if we had this is just the first quadrant in a coordinate grid. And if we started graphing data ordered pairs, and the data, maybe we had points that look something like this, and they're sort of, okay, they're not going to be necessarily on a line, okay, but we can see that the data collected, okay, has a positive correlation because if we did put a line through those points, okay, a line of what we call best fit, it would have a slope that was positive. Okay, so that's a positive correlation. A negative correlation, okay, would happen if we plotted points and as our inputs increased, the outputs would decrease. Okay, so maybe it would look something like this. Okay, and in that case, if we drew a line, it would have a negative slope. Now, if we captured data, and we do this a lot in science, and the data was all over the place, okay, that would be no correlation. Okay, so just thinking about scatter plots and gathering data. Okay, so our first example, what we're going to do is show you how to capture this data using Desmos and then making a scatter plot on Desmos and then using the tool to actually do a trend line or line of best fit. Okay, so the table shows the amount of time required to download a 100 megabyte file for various internet speeds. Assuming the trend continues, how long would it take to download the 100 megabyte file if the internet speeds is 75 kilobytes per second? Okay, so what we're going to do here is we're going to take this information, our input values, okay, would be the internet speed, and our output values, okay, would be the time to download. So X's and Y's. So we are going to use Desmos, and I'll pull up Desmos right here for you, okay, and let's just make sure we can pull that in. Okay, and what we're going to do here is we're going to create a table, and how we create the table in Desmos, you're going to click on this little plus button here, and you're going to create a table. Okay, so notice the column header is X1, Y1. So our X values are going to be the internet speed. So I'm going to put in 35, I've got 40, I've got 45, 50, I've got 55, and I've got 60. Okay, those were my input values. When my input is 35, my output is 6.65. Okay, that's going to be 6.65 minutes. Then I've got 5.82. Okay, I've got 5.17. I've got 4.65, 4.23, and I've got 3.88. Okay, so I just created my table with the data. Now this is really important. See how I have the X1 and the Y1? To get the linear regression or the trend line, we get the line of best fit. So we're going to use Desmos calculator. We're going to type in Y1, okay, and you've got to put the Y1 because that's using the Y1 here, okay? And then we have this button called a tilde, and it's actually, okay, it's like this little kind of squiggle line. It's above the tab. And then we're going to type in AX1 plus B. Okay, so what this is doing now, all right, I'm going to move the screen a little bit and kind of come out so you can see the data that we got. There it is. All right, so if you notice, okay, the ordered pairs that we put in are over in here where the dots are, and the line it created, all right, this is a negative slope, okay, and it gives us the line of best fit. So it's taking the averages, the trend line, and creating it. So you can look at your parameters now, and your A represents your slope, and the B represents your y-intercept. So notice your slope is negative. Okay, so the directions in the notes say to say A, but I also recognize you can put in an M if it's easier for you because we know the equation of a line is y equals mx plus b. And when we do that, our parameters then is an M. Okay, so when we go back to our notes here, okay, let's just fill it in. All right, so we click on we get the tilde. We write down our A and our B. So our A is going to be negative 0.1, and our B is 10.3. So we can write our equation as y is equal to negative 0.1 x plus 10.3. All right, so, 10.3. Okay, so there it is. That's the equation of the line of best fit. And then it says, the second part of this question says, okay, what would it take if we had an internet speed of 75 kilobytes per second? So what it's asking is, if we had an input of 75, how long would it take to download? So we just use that equation, and now we just let our x be equal to 75, and we plug it in. Our y is going to be equal to negative 0.1 times 75 plus 10.3. And we follow our order of operations, and we end up with y is equal to 2.8 minutes. Okay, there we go. All right, so I want you to pause the video and I want you to try the next example. All right, the next example says, okay, use the data. Okay, we're going to, let me just move this up a little bit so you can see it. Use the data in the table to write an equation that models y as a function of x. Round your answers to the nearest tenth. So we're going to, this one is going to be a linear function, so it's going to be a line of best fit. And I want you to put your inputs, create your table. All right, so when I go to create my table, I want you to be really careful. Okay, I'm going to come back over here and notice that I'm going to start by deleting this table, because if I come over here and I create a new table, watch what happens. Now my x2 and now I've got x2, y2. So notice this first table was x1, y1. It's fine if you have x2, y2, but what's going to be really important is that when you get your equation, you use the x2 and the y2 in that, okay? So I would prefer that you actually just get rid of the other ones and start over, okay? Now, when I add my table, notice I've got x1, y1, okay? And again, I just go through and I put in my values. I've got 1.2, I've got 1.8. These are all my x values, okay? I've got 2.3, I've got 3.0, I've got 4.4, and I've got 5.2. These are all my x values. Now when I put in my y values, I've got 10, I've got 7, 7, then I've got 5, negative 1, let's make sure we get the right ones. There's a 5. Then we've got a negative 1, a negative 4, and a negative 8. Okay, so you can see here on the graph, we've got our points. Now when I do my line of best fit, all right, I'm going to type in y1 tilde, all right, ax1 plus b, and I got my line through it. So here my a, or my slope, is negative 4.4. I'm rounding it to the nearest tenth, and my y-intercept is 14.7. Okay, so I can actually come over and let's just write that in. Okay, I'm just going to move this over here. Okay, so since our A is for negative 4.4, and our B is 14.7. So when we write the equation, it's y is equal to negative 4.4x plus 14.7. Okay, so I've got a number of examples here for you to try. Okay, you can try 2, you can try 3. Now, this one right here, this actually second one. Then you can predict how much a $40 kite would be. So you're going to let your x be 40 and figure out what the quantity is after you get the equation of your trend line, or your line of best fit. Okay, but for purposes of time, I want you to go out to the key and check out the answers there. All right, but then now I wanted to show you how we use Desmos to determine the curve of best fit. So the first ones were just linears or lines, but now we're going to use the curve. Now, if you recall, a curve is a quadratic, okay, and in standard form, that would be, we've got y is, so it's going to be ax squared plus bx plus c. Okay, so that would be it in standard form. So it's going to be very similar. So in this example, Dave hit a golf ball from the top of a hill. The height of the ball above the green is given in the table below. So after so many seconds, you notice the height is 52.1 after 1 second. After 2, it goes to 73, 74, but then it starts to fall, okay? So now after 4 seconds, has hit the peak and now it's coming down. So this would be a curve of best fit. So if you notice, we're going to use the Desmos graphing and we're going to plot the data points. So we did that here the same way we did line of best fit. And you can notice the points, there they are. Okay, so what's going to be important though is that instead of doing y1 tilde for a slope, y equals mx plus b, now we're going to put in y1 and then we have that tilde, ax1 squared plus, or ax1 squared plus bx1 plus c. Okay, so that's what we want to do there. And when we do that, if you notice, it makes this kind of zoomed in, but it makes the curve of best fit, and it gives you the values right here of your A, B, and C. So in your notes, we just wrote down our A was negative 10.1, our B is 51.4, and our C is 11. So we just plug it into this form, which is y is equal to ax squared plus bx plus c. And we plug in those A, B, and C. And that's how we determine the curve of best fit using Desmos. Okay, so we can then take that curve of best fit, okay, that we have, and we can use it to make some predictions, okay? So what I'm going to do is just write down the equation here again. So it's y is equal to negative 10.1 x squared plus 51.4x plus 11. So we want to see how high the ball would be at 0 seconds, because if you remember, he was on a hill. Okay, so we're just going to take it and we're going to let our x be 0, okay, because it's 0 seconds. So our y is negative 10.1 times 10, whoops, that should be times 0 squared. Whoops. All right, so that's times 0 squared plus 51.4 times 0 plus 11. So our y, following order of operations, we end up with just being at 11. So it's going to be at 11 meters. Okay, so 11 meters. All right, we're going to do the same thing for 2.5 seconds. Now we want to know how high it is. So we're going to let x be 2.5. We're going to plug it in. So we got that answer. And now we've got y is equal to negative 10.1 times 2.5 squared plus 51.4 times 2.5 and plus 11. Okay, we follow our order of operations there. Okay, and we end up with 76.4 meters. Okay, so when does the ball hit the ground? All right, what you need to do there, you got to be really careful, but you got to zoom in. Okay, so we're going to look at our curve of best fit. If you notice here, okay, in the previous screen, we're going to zoom in and we're going to see that it actually right here, and you're going to hover over it, and that's going to tell you where it hits the ground. So when you do that, you're going to find out that it hits the ground at approximately 5.3 seconds. Okay, all right, so approximately 5.3. Okay, all right, so that was using Desmos, okay? So I want you to, again, use Desmos with the following examples. Go back to the answer key and see how you did. So curve of best fit, remember it's y1 tilde ax1 squared plus bx1 plus c. Okay, so that would be for the curve of best fit, and the line of best fit would just be y1 tilde ax1 plus b, okay? So try these examples using Desmos, get some practice at it, and then check it with the answer key that's on Schoology. Okay, so analyzing the data. So we need to decide, is it a line of best fit or a curve of best fit? So you've got to look at the data and see if there's a relationship between the fat grams and the total in fat. In this particular example, is there a relationship? So when we look at this data, and we put it into Desmos, okay, here it is in Desmos, okay, you can see that it's actually a linear function. So this would be line of best fit, and that's why we would use the y1, okay, tilde mx1 plus b, all right, and we would get our answer, okay, that would be the line of best fit, okay, all right, so I hope that helped. Bye.